Hey guys, welcome back to the GE10T1 restoration series. I have basically finished the recap. All the paper caps have been replaced, the electrolytics, which are scattered all over the place. We've got some on the top, we've got some adapter caps, we've got some axial caps. These are not fun to work on if you haven't picked up on that already from the previous installments. Okay, I've populated the tubes. I'm going to throw caution to the wind a little bit, and that the selenium rectifiers are still wired in. I'm curious to see what it'll do with them in place. So, without further ado, here we go. Alright. Watching the current draw. It's 0.4 amps. About 0.8 amps. Normally I would have powered this up without a rectifier in place just to see the tube filaments glow, but it's a series strong set with selenium rectifier, so there is no rectifier tube to pull out. Well, this has some old-timey thermistors in it called glow bars. It takes a while for these things to warm up. What tube filaments are online, it looks like. Some are a little faint, but yeah, I think they're all glowing, including the CRT. But what we don't have is any glow on the face. Alright, let's use the old trick to check for high voltage here. Oh yeah. Nothing on the CRT. Let's see, it doesn't have this hooked up to a signal source, but I forgot to turn it on, so let's get that going. Yeah, I've got it hooked up. I've seen some sets where if there's no signal, instead of seeing snow, it'll kind of be blank. Oh yeah. Yeah, it's faint. But yeah, interesting. So without a signal source, you don't get anything. Boy, that's not very bright, is it? That's brightness all the way up. So let's verify that. I'm gonna turn the signal generator off. Yeah, with no signal, the picture blinks out. Interesting. Well, that's fantastic. So no smoke. Alright, so it's really dim. Can we lock onto anything? We're on a crosshatch pattern, so we should see a checkerboard. Adjusting horizontal and vertical hold. They're doing something, but it's not really locking too well, is it? That image is so dim, it's kind of hard to tell anything. Well, I tested all the tubes. I found some that were kind of in the questionable zone and replaced them. I then played around with the controls a bit, and I in particular adjusted the horizontal oscillator frequency coil, and that enabled me to get a lock. Clearly we've got a major problem going on here. That's as bright as I can get it. Two, we've got a dark band moving slowly, so that's got to be 60 hertz ripple getting into the system, because it's just slightly off the vertical oscillator frequency, which is like 59.97 hertz, something like that. So just slightly off from what the line frequency is, which is what the black band would be. What could that be? It could be ripple in the power supply. It could be ripple getting into the video amp. That could happen if you have a heater cathode short in one of the tubes. I just checked them all. I didn't see that, so I don't think that's what it is. I started my troubleshooting by tracing out where the brightness control goes, and it goes to pin 11 on the CRT. So I put my ohm meter in that, traced it back out to where it goes, and I wasn't finding any continuity. And you know why? Because I forgot to connect it back up. It's supposed to go on this terminal strip board here, right on that lug. So it's been open, and that is a very important element on the CRT. It was cathode, so without that, not going to work too well. So let's get that hooked up, shall we? Made so much of a difference. We have nothing now. What the heck's going on? Man, I am having some serious deja vu. I have to go back and watch the video, but I'm pretty sure I did something very similar, maybe even the same control, the last time I restored one of these. Have I mentioned I don't like working on the early GE TVs much? Yeah, this is why. The controls tend to be bad. So I have unmounted the brightness and contrast control. This back section is for brightness, and as we can see, it's totally open between the two outside terminals. Should be 200 or 500K rather. So open is no good, and the other one should be 2 meg. It does have continuity. It's a little low, 1.6 meg, but when I rotate it through the range, it's really flaky. Sorry, not showing open. If it rotated a little bit, it kind of jumps around. And yeah, so this one might work, but it would be touchy. Well, at least it has continuity. This one is totally open. This is one of the big problems with working on these early TVs. It doesn't happen often, luckily, at least not on the better made sets. It's not often I've encountered bad controls, but when they are, they can be tough to replace because they're specialized. 2 concentric controls with shafts custom tailored to the types of knobs in this set. Yeah, I can get a 250K pot, or sorry, 500K pot, I can get a 2 meg pot. Concentric, if I hunt around, yeah, they're not going to be this exact shaft type, unless I get really lucky, really lucky. There were universal replacement kits. Occasionally they show up on eBay, usually they're bidding complete, but what they would have is they would have the individual resistor sections, different types of shafts. In other words, you could cobble something together. Or they would have types of shafts that could be cut down and made to work. I have saved them from sets over the years, but GEs are kind of specialized because they use these goofy knobs that no other maker used. So I can go hunting. Even if I can't, I could certainly take controls and temporarily tack them in place to get the set working. But what I'm also going to try doing is taking this apart and seeing if I can fix it. What is it hung up on? Oh, no. There's something else going on here. Now I see what happened. Looks like somebody cranked so hard on the knob. The contacts that slide along. Let's see if we can compare these two. You guys can see that, but on this guy, there should be 2 pieces of brass that come down with little pads that rub on the carbon. On this guy, the left one's gone, completely gone. And the right one was mangled, like this had been rotated around and it smacked into these and they broke one of them off. The other one is still there, and if I can unmangle it, it just might be enough. Unfortunately, there's a brightness control, which gets a lot of use. When I do this right, I really want to be able to open this, to take this thing apart. Alright, so I got that wire out of the way. There's something else holding this in. Man, I hope it's not that they put this through and they I don't know what you call that. Spread these apart. You put a tool in there and peen it over. Meaning it's not meant to ever come apart again. I think that's what they did. Oh, crap. And yeah, maybe where that came over, it smacked into this one so hard it destroyed the carbon track. Huh. Get out the ohm meter here and see if we get any kind of continuity action going on. So it looks like it works over a certain range now, but not all the way from one side to the other. And the way this is used is there's a voltage on one side and ground on the other, and this goes between them, so it absolutely has to have continuity across the whole thing. To do that. That's just too messed up. I gotta have to replace that. That's a shame. Well, I bypassed the brightness control with a 100K resistor and a 390K. So it's 500K pot. I put the tap towards the bright side. So we now have a bright image. I can't control the brightness, but we've got an image. It's blurry because this shouldn't have a focus coil on it, and it does. We should be used to that by now, but yeah, it's a nice stable image. I'm surprised given how chewed up this set looked to be. While I was tinkering down with that pot, I did replace the selenium rectifiers with a couple 1N4007 silicon power diodes, and I beefed up the surge resistor, which was 4.6 ohms. 4.6 ohms. I put a 5.6 ohm in there. I'll check B plus and see if it's within range. If it's higher than I'd like it to be, I can increase that resistor a bit. But yeah, otherwise we're looking pretty good. So the hunt is on for a replacement pot. I did start digging through my junk bin, and I tacked this one in because the 2 meg section was kind of flaky too, and I wanted to see what result that would have. So that's contrast. So contrast is working very nicely. But alas, the back section on this is 500 ohms, not 500K. So that's not gonna work. But at least I cleaned up the wiring in there and got the old control out, so when I find an appropriate one, it'll be easy enough to pop it in. One other thing, perhaps, well, potentially it could have been 2 other things, but just one other thing. Turn this set off so I can pop the schematic up on top of the set. This set has 2 germanium diodes. It's a change they made over earlier incarnations. They use one for the detector, and they added DC restoration. The earlier versions of this chassis do not have DC restoration. That diode was bad, so I had to dig in there and replace it. Here it is. Kind of a crummy looking thing. It is a GE diode, so I guess they made their own, a 1N65. It's not obvious what end is what. It's not really marked on here. They do show a little picture, though, showing that the pointy end, they show as being positive, which would be the anode. I wired in a new germanium diode, well, a new old stock germanium diode, with the cathode bar in the same direction as this. I tend to ignore any plus minus type symbols they use and just go with the diode symbol. Same with these guys. Gets kind of confusing because what they show the cathode, they put a plus next to it. Just on your modern diodes where you see a line, make that go with the line on that. So cathode, cathode. In other words, the schematic symbol is correct. Ignore the plus minus they throw on there sometimes. That does not necessarily mean anode and cathode the way we think about it these days. There is my replacement germanium diode tacked into place. And while I was in this area, I thought I'd check a few other things, namely the peaking coils. See one there, and one there, and one there. And guess what? I found one that's open back in there. I think that's on the sync separator. Or maybe that's the video amp. I gotta double check. So yeah, sure, it's open, because why not? Why not keep the fun rolling? But we can get a signal coming through. How does that happen? Well, if you look close on most vintage sets, these coils are wrapped around resistors. So on the core here, it's not a ferrite rod or anything, it's actually a resistor. In this case, it's 8.2K. So the coil's open, but the resistor keeps the signal going through. So it'll still work if the coil's open. And depending on where it's used and how it's used, you might not even realize it. What is the effect? You'll have less bandwidth. So these coils are called peaking coils. They're there to shape the response, typically the video amplifier, the final amplification stage, to get to help out the high end or the low end, and get a nice even amplitude across a range of frequencies. So with it being open, yeah, you can still get an image, it'll be degraded. Now as far as replacing them goes, what do you replace them with? Well, sometimes the schematic will tell you that maybe it's 120 microhenries, but that's not the whole story. We don't know what the Q factor is, the quality factor. We don't. There's inductors, and then there's inductors. And notice these, it's not just a coil of wire, it's like two pancakes with some space in between. They have certain special characteristics. So what am I going to do? I don't know. I'm sure I don't have the exact type in here, nor do I suspect I could find one. I'd have to basically find one of these chassis and snip the part out of it. So the question is, what's better? Leave it like it is, just short it out with a piece of wire, or get an equivalent modern inductor and figure even if the Q's off, it's better than nothing. I'm not sure. I'll know more when I get the full-size CRT installed and we can see what the image quality is actually like, and then we can do some experimentation. But that'll come later. So one thing I've been puzzling over is when I first powered this up, I did get a ghostly image. Now, how was that possible? If the brightness control was shot, that means there's nothing getting to the cathode from the brightness control. But we do have a couple other things going to that cathode. We've got 0.2 microfarad filter cap. That probably wouldn't do anything. But this line, that goes also to another cap, which goes over to the vertical output transformer. Yeah, this has vertical retrace suppression, which is a pretty novel thing for the late 40s. Most sets did not use it. So, is it possible that from pulses of this, and this resistor and this capacitor, could that have built up enough charge on the cathode that electrons eked their way over to the screen and we got a really faint image? I guess so. And the grid biasing was way off because this diode was bad. So I find it remarkable that with those two problems, we got some type of image on this. But what a difference it made bypassing or replacing those two components. I reinstalled and wired in the speaker, and it seems to be working all right. So, what can we do at this point? Well, I gotta scrounge up a replacement control. Until I do, I can't change the brightness without altering those hardwired resistors down in there. So I'll keep looking. I've gone through a couple junk boxes. I haven't come up with anything like I need. And I looked on eBay and didn't find what I need. So again, the Early Television Foundation Convention's in a few weeks, so I may just put this also, just to sit along with the Philco in the back burner until I can go there and see if I can scrounge up the part I need. But there is one thing we can do right now, and that is get back to the full-size CRT. I believe I need to put a new DAG coating on it. Let's get that up on the workbench. Here it is. Yeah, it's coming back to me. Most of the DAG coating fell off. I'll scrape off or dissolve off with acetone what's remaining on here and mask it off. We want to stay away from the high voltage connection, so don't spray any around here, and don't want any near the yoke. You can see where they sprayed the original. Looks like they went down here, they went around, looped around the back, and went up to around here. So they didn't spray anything in this whole area. So we'll get out some newspaper and masking tape and whatnot, and then we're going to spray on slip plate graphite lubricant. It is pretty darn similar to what they used back then. So this is a rebuild, and feel where they welded the neck back on here. Really nice shiny getter on it. Tested 10 BP4B. I think the B means it has a certain type of faceplate. It's not gray, it's not frosted. So I'm not entirely sure what the B means. At any rate, this is the Midwest, and we don't really have spring. We just oscillate between summer and winter in the spring months. So, it's pushing 80 a few weeks ago. Now it might snow. So, I'm not sure exactly when I can spray this. In other words, it's too cold outside to spray. But I can clean it off. I can mask it off for now. So, yet another. I scraped off as much as I could. Some of this is actually stuck on there pretty well. I scuffed it up so that this should adhere to it pretty well. I'll dig up some newspaper and mask this off, and we're going to be spraying in this, but not today. So, that's going to be it for this project for a few weeks, I think. Meanwhile, I still have a bunch of other sets from this owner, including 2 RCAs. I think we'll dive into those next. I know he's very anxious about one of them in particular. I think they're both the same chassis. One's a tabletop, one is a console. Late 40s RCA type, 10 BP4, bunch of Adaptacaps, whole mess of paper caps to replace, and I think some rodent-inspired corrosion. So be looking for that in the next upcoming series. Thanks for watching.